Everyone, this we're going to solve this question today. LeetCode number 3761, minimum absolute distance between mirror pairs. So they have given a definition for a mirror pair, which is a pair of indices I comma j. If you notice, j must be greater than I, and the reverse of the num I must be equal to j. So if you're standing at j here, then I will be here somewhere behind it, maybe this section, right? The possible areas where I can be, and the reverse of this number of any index between this range must be equal to j. If that is the case, then you should find the absolute difference and return the minimum absolute difference between I and j. They have defined reverse as reversing the digits. So if for 1 2 3 means you get 3 2 1. If you have 1 2 0, you can ignore the zeros will become 21, so it's fine. You can omit the leading zeros. So this is the question. So the main approach you have to think about when it comes to this question is so the main approach would be to have a hash map where you store all the mirror pairs. So the keys will be the mirrored versions of the number, and the value would be the index at which they are found. So let us define first a reverse function. So reverse num while num is greater than 0 is equal to 0, rev is equal to rev into 10 plus num while 10. We have a reverse function. So let us go through each index in the list nums. So like so, let's define hash map. You can call it mirror map, and let us see if reverse of nums of I in the stored as a variable. If rev is in mirror map, then we have found a pair. Imagine you're traversing you should check if nums of I is in a mirror map. So if you have seen the correct number before in mirror map, that means it's right. For example, 21, 12 might have stored its value, it might have stored its reverse in the mirror map. So let us take this example. So 12, when you have encountered 12, it wouldn't, the dictionary would have been empty, right? 12 requires 21, so let us store 21 0. Then when we encounter 21, we see the reverse is at 0, so these two make a valid pair. So we can just do j minus I absolute, it is 1, and we can just minimize this value for each of the valid pairs. So like this we can find valid pairs. We can store the reversed value in the hash map and the index at which this reverse value is needed, and whenever we encounter a value which matches this reverse value, the value is 0. So basically, to summarize, we keep a hash map which stores the reversed value and the index at which this reversal is needed, and we traverse the array. If our value matches any one of the reversed value in the hash map, that means that is a match. So basically the number at index 0 matches with the index j, right? So they make a valid pair. and we can find the absolute difference and then try to minimize it. So nums of I is in mirror map. If nums of I is in mirror map, that means you have found a valid pair. So we can have a value as answer float of infinity, and the answer is equal to min of and absolute difference. So the difference would be I minus mirror map nums of I. And if it's not, we can just store the reversed value in the hash map. So mirror map nums of I reverse. You can just uncomment this and use this, or just equal to I. So in an interesting case comes when there are duplicates, right? For example, imagine there are, like, there's a 12 here, there's a 12 here, and there's 21 something, 10, 15. So in this case we update the dictionary, right? We don't want to make valid pairs with this, right? We want to make valid pairs with this should be matched, since the further distance, it makes sense, right? Because it's further. So we always replace the dictionary index if they result in the same reversed value. Okay, and now we return ans. Syntax mistake here. And if ans is equal to float of infinity, which means we haven't found a match, is written -1, return ans. Yes, submit, and it passes. If we Yeah, it passes, yeah. Here they've used string operations, which I think are faster for reversal. So I think that's why there is a peak here, but the core logic is the same, right? So that's it for this question.